So now we move on to question 4. In this question, we're given this force of interest, and we want to find I2. So what exactly is I2? So I2 is the effective interest rate earned at from time 1 to time 2. So if I start at time 0, so I accumulate up to A1, and then I end up with A2 at time 2. So by definition, A1 and A2 are related in this way. So the effective rate of interest is going to be equal to this expression. So for this problem, if we want to find I2, all we have to do is to find the function, the accumulation function, AT, through this force of interest. So the force of interest is equal to 0.2t divided by 1 plus 0.1 t squared. All we have to do is use this to find AT, and then just to substitute t equal to 2 and 1 to this expression, and then we'll find I2. So what is AT? So by definition, this is equal to this expression. So once again, you can use the definition of a force of interest and then apply, and then to solve the differential equation, and then you'll arrive at this expression. So in case you're unfamiliar with all this, there's actually a more general formula that looks something like this. So you see that this is kind of like a special case of this formula. So you substitute 0 for t1, and then because a0 is always equal to 1, so you get this expression. So there's a divided by 1 down here. So let's try to solve this interval. So in our case, we have 0.2. I'm going to change it for a y because there's already a t up here, so I can't use t in the integral dy. And then we're going to use substitution. So we're going to let u equal to 1 plus 0.1 y squared. And then if we do our substitution, we get 0.2 y. So you see that du is actually equal to 0.2 y dy. So 0.2 y dy, that's equal to du. And the denominator, that's just equal to this, right? So it's just equal to u. And then for the upper and lower bounds, for the lower bound, you just substitute y is equal to 0, so you get 1. And then for the upper bound, you get 1 plus 0.1 t squared. And then this integral, 1 over u, is just natural log of u. And then now you can substitute the numbers in. So minus -1. -1 is just 0, right? So we can get rid of that. So we have e to the power of natural log of this expression. So at is just equal to 1 plus 0.1 t squared. Because just recall your logarithms, e to the natural log of something is equal to that something, right? So this expression is just 1 plus 0.1 t squared. So going back to our original problem, we would like to find I2. So we can just substitute 2 inside, so we get 1 plus 0.4. Substitute 1, we get 1 plus 0.1. At the bottom, we get 1 plus 0.1. So the ones they cancel out, you get 0.3, you get 1.1. So I2 is equal to 3 over 11, which is equal to 0.272727 all the way to infinity. So this is question 3.